Having done that, we're going to look at the concept of functions. Okay, and across the line, I'm sure we've all seen various kind of functions, and usually we call them as equations. Okay, yeah, but there are different kinds of equations with different rotations. So let's see some examples. So for example, you may have met an equation like this: 2x plus, okay, 3. You may have seen an equation like this. Another equation you may have met will be y is equal to x squared, okay, plus 2x minus 3, okay. Then you may also have met equations like this: y cubed or x cubed times y plus maybe 2y minus x, okay, equal to 0, something like that. Okay. Yes, and then we've also come across several types of equations, some in trig form. So we can have something like cos x plus sine. Okay, let me make it a popular one: cos squared x times sine squared x equal to 1. Okay, so these are all equations or functions we have met along the line of our study. And clearly you would admit that they are all in different forms. Okay, they are different types of what? Of functions. Okay, and our study this morning is about function. We want to know basically what a function is, and how to plot a function. What do we mean by domain of a function? What do we mean by range of a function? And what are the types of functions? Then most importantly, how do we plot these functions, or how do we graph these functions, both manually and using software? Okay, and the software we are using in class today is Scilab. Scilab. You can easily download it from the web, okay, and use it for your own studies, your personal studies at home. Okay, good. So basically, when we look at these functions, let's take the very simple, okay, example here and demonstrate it. What this simply means is, if we are given a set of values, x, okay, let's say x belongs to, or x is a given domain, okay, starting from -2 to 3. When I say -2 to 3, close, you see this is a closed interval. This is also another closed interval. So let's try and understand what we mean by closed interval too before we proceed. So that simply means that x is the set, okay, an interval of elements 2, okay, starting from 2. If probably, let's say x belongs to the set of what? Natural numbers or integers. Okay, good. Then x will be -2, -1, 0, 1, 2, and 3. Okay, so these are the elements in the domain, okay, x. Right? Good. So which means that we would, if we have to find y, we would have to substitute each value of x into this function. Okay, so for the first value of y, we'll write if x if x is equal to -2, okay, then y will be equal to what? 2 into bracket -2 plus 3, okay, and then the 2 into bracket is off, so bracket is the same as multiplication, so 2 times -2 will be -4, okay, this equals -4 plus 3, okay, so -4 plus 3 is equal to what? -1, okay, good, and then you repeat for the rest, okay, so if x is -1, if x is equal to -1, then that will be y is equal to what? 2 into bracket what? -1 plus 3, okay, and that will be 2 times -1 will be -2, okay, plus 3, good, and the -2 plus 3 is equals to +1. So basically what we are saying is this function, as we see, and I'm going to write it more in the functional form, okay, in the generalized form, we are going to write it a function of x, okay, is equal to 2x plus 3. Good. So this means the same as this, which means that if we compare, then it means that f of x, okay, f of x is equal to what? Is equal to y, okay? Now, what does this mean in terms of its interpretation? What we mean is a function is just like a machine, okay? Good. A function is just like a machine, okay, which takes on an input. So let's say we have the function here. So it takes an input, say x, and once it takes the input, this function says anything that enters into me, I'm going to multiply that input by 2. And I'm going to add 3 to it. So at the end of the day, I'll generate an output y, okay, an output y, and y is simply the image, y is the image or the output, okay, so y is the image of the input here, okay, y is the output or the image, okay, so if you put, say, like we've already done here, if you put -2 here and it enters into the machine f of x, f of x is I'll multiply it by 2, so I'll get -4, then I add 3 to it, so -4 plus 3 will give me -1, okay, so a function is just like a machine, it's just like a rule, it's a rule, okay, so once anything enters into it, we apply that rule and then it gives us an output, okay, so in mathematics term, we represent functions like you have seen. F of x is equal to 2x plus y, okay, good, or sometimes we write it like this: f operates on an input x and then produces an image y, okay, so this is another way in which functions are denoted. Now, so basically, what we have said so far is a function is like a machine, it's a rule. It's a rule which connects a certain input to a specific image, okay, a unique image, okay. So a function is a rule which relates what an input, say x, to a specific or a unique image say y. Okay, good. Now we have different kinds of functions. We'll be looking at that later, but we want to delve deeper into functions and then try to identify what the rule is all about. Okay, and when I say try to identify what the rule is about, what I mean is assuming we've been given, let's say, data like this in a table form. Let me use this type of table. So vertically, so assuming I have table, say x and y, okay. You know, y is our images and x is the domain, right? Yeah, so let's say we have from 1, yes, 2, 3, 4, and then I have say 3, let's say 6, 9, 12. Okay, then the question will be, what then will be the next element? So if you know the next element, type it out for me on the page. What will be the next element? Yes, very good. So, and quite a number of you have indicated 15, and 15 is the answer. Now, the question is, how did you get 15? So, if you want to answer that, just raise your hands and I'll mute you. How you got 16, 15. Okay, if you want to answer that, raise your hand. So I'll ask Elvis to come in. So Elvis, you can answer that.
Okay, so I added 3 times the x. That gave me the y.
Okay. So Elvis realized that there was a common difference of 3. Okay, so we keep adding 3 on, right? We keep adding 3 and 3 and 3 and 3. Okay, so it's more like y is obtained with the first element is 3, and then subsequently we add on 3, okay? Taking into consideration the x minus 1, that's the first term minus 1, okay? Good, so if we simplify this should give us what? 3 plus what? 3x minus what? Minus 3, okay? Which basically gives us 3x, okay? Good, so the rule here is y equals to what? Is equals to 3x, okay? Good, so that is one way we can find the pattern. Another way we can find the pattern is because this is more like it's an AP, which makes it a linear pattern. Okay, so we can have something like mx is in the form of mx plus c, where m is the gradient. Okay, so m is y2 minus y1 over x2, okay, minus x1. So it means we can select any x and any y. So we can select this as a y2, x2, and then this as a y1, x1. So that will give us y2 is 6, and then x2 is 2, minus y1 is 3, x1 is 1. Okay, so 6 minus 3 is 3 divided by 1. So our gradient is what? Is 3. So that gives us y is equal to what? Is equals to 3x plus c. Then what next? We can select y1, okay, x1, and put into this equation to get our c, okay? So doing so, y1 is 3, is equal to 3x1 is 1, okay, plus c. So which means that we're going to get 3 is equals to 3 plus c, okay? Now moving 3 to the other side will give us a negative, okay? So that gives us minus 3, okay, plus 3 is equal to c, which will imply that c is equal to what? C equals to 0, okay? So once again, when we put that, we substitute that into equation star here, okay, we are going to end up with y is equals to what? 3x as our what? As our function, okay? Good. So these are some approaches we can use to determine what the rule governing what the given domain and images, okay, on the table in the table. Okay, now let's proceed. If there's any question, you can raise your hand. If there's any question, you can raise your hand before I move from this. Okay, let's move on. The property that each input has exactly one output. Okay, and the first thing that comes into mind when we talk about relation is a link between two things. Okay, good. So when you go to Facebook, the first time you set up your account, by the time you finish setting up the account, okay, you have recommended friends, okay, for you. Then the question is, how did you know, how did the computer know that these are your recommended friends? It's because you stated a rule that probably you completed this school in this year. So what the computer will do is it will how do you call it, mine for all individuals who completed that institution in that year and present them as what? Possible friends, okay? Because they were your classmates. So once they were your classmates, it's likely they are your friends. So a rule or a relation, okay, links one object to the other. Now, in a function, what we are saying is we cannot have the rule linking one person to many people. It can only link one person to another person, just singular. Okay, and then in practicality, this is what it means. If you put tomatoes in a blender, the function on that is to blend to a puree, you are expecting a puree at the end of the day. So if you end up having a let's say condo after blending, you'll be very surprised and amazed that what kind of blender is this? Okay, because it's not supposed to happen. So when such a thing happens, we call it an invalid function in mathematics. Good. Another practical example will be having a rocket which has been designed and programmed, okay, based on some functions and some rules to land in the moon. But this particular rocket, based on that function, could either land on the moon or on the sun. And if I ask you whether you want to be in this rocket or in this launch, you tell me no, because you are not sure whether you land on the sun and fry or you land on the moon. Okay, so functions need to have a rule that leads from one object to a unique image. It's very important. Now, the object which the function picks on, okay, and maps is usually referred to as the input or our x, and they are usually in a set called the domain. And the images of the x are referred to as the range or the values of y. So practically, this is how it looks like. In the lower stages, we usually represent them like this. You have your domain X. I wish I could use, let's see. Okay, no problem. Let me use this screen. So you have your elements of the domain X, and then the elements of the codomain Y. Okay, good. So we take elements X within the domain, and then the function maps to elements Y. Okay, so F will map X to Y. This is what we mean. Okay, now moving on. I have a, okay, I think we'll skip this part since that has been well explained earlier. The value of the input is X. Then all you do is to put in the value of X or substitute the value of X. Okay, so if X is giving us -3, then just put it into the function. By putting the function, this is how it will look like. So we have, you are just putting the values of X, okay, wherever you see X in the function. So you put it into X here. So we have 3 times minus X raised to the power 2 minus -3 in bracket plus 2. Okay, you see X itself is -3. So when you are putting it in, put it into brackets. Don't get confused and say there is already a negative here, so let me bring +3 here. No, there is a negative outside. So when you are substituting your -3, put it into brackets here. And again, when you are also squaring, put that into brackets and square it. Okay, so that you don't make a mistake. Good. Then once you are done, you simplify it. Okay, the same way if X is giving us let's say a combination of terms or an algebraic expression, you need to follow the same rule. Substitute X wherever you see
M+3.
yes. So you substitute your M+3 wherever you see X. Okay, good. And then what you get as a result is what we have here. So we're going to have M+3 squared minus M+3 plus 2. Okay, then you expand this one as M+3 times M+3. Okay, good. And then after that, you can multiply. That would be M times M will give us M squared. M times 3 should give us what? 3M. Then we have 3 times what? M should give us 3M. And then 3 times 3 should give us what? 9. Okay, good. And then simplify the ones in bracket to M times -1 will give you -M. 3 times -1 will give you -3 plus 2. Okay, and then you group like terms and simplify to get this algebraic expression. Okay, so moving on.
Sir,
Yes.
please can you go over the F into bracket M+3 once again, please?
Yeah, the multiplication is M+3 squared is the same as when we say something squared, it means the same thing times itself. Okay, so it will be M+3 times M+3. So when you are multiplying, you either distribute this way or you can distribute that way. So M times M will give you M squared. M times 3 will give you 3M. Then 3 times M will give you 3M. 3 times 3 will give you 9. Okay, then here to M times, this is when you see minus, it is -1, and there's 1 in front. So it is M times -1 will give you -M. 3 times -1 will give you -3. Then you bring your +2 and then simplify it. Okay, When you simplify, this will give you what? Just group like terms and then simplify. That is what I'm saying. Okay.
Say thanks. Thank you.
You're welcome. Yes, Emmanuel. Emmanuel, speak.
Hello, sir. Please, sir. My question is, when you read the binomial expansion, please, sir, can you work it on like where you are doing the work, or you should work it on another sheet so that when you finish, you bring the answer?
No, I want to see the steps. So in any examination or any assignment I give you, make sure you indicate the steps. I'm not interested in the answer. I'm interested in the process and the answer. So if you skip the steps and give me the answer, you lose a lot of mark. Yes, Katira. Katira, you have your hand up. Katira Tete.
Sir.
Yes.
Oh.
I want to believe this section is well explained, okay, after going through the samples over and over. But if there is any other question, you can raise your hand. So I'm going to forward it a bit. Okay, if you're having difficulty, just type your question in the chat for me. Okay, I think I have some hands up. Emmanuel and Ketia. Ketia Emmanuel. Emma, you can unmute yourself.
Square plus 5m plus 8. Would that be the final answer?
Come again, please.
I said the 2 m square plus the 5m plus 8. Will that be the final answer?
Yes, that will be the final answer.
Okay.
Okay, next person, Jabril Mohammed. Jabril Mohammed, you can unmute yourself.
Sir, please, I want to ask of the PDF, how can we get access to the building mass, the PDF notes, and so that we can learn more about it?
All my slides will be posted on the LMS for you, and all the
Okay,
links to the videos. Okay. So
okay.
never don't bother about my content at all. All you need to do is to go to LMS. You will get all the materials plus the links to the lecture videos.
Okay, sir.
Let's move on. So the next thing we want to understand is the concept of domain and the concept of the range. Now, when we talk about the domain, first of all, you have to know they are the values of X. They contain the input values. So you remember when we do the first charts, we said the domain is the values of X here, and the codomain is the values of Y. Now, when we come on the graphical representation, this is the X-axis. So the X-axis contains the values of X. And then the Y-axis contains what? The values of what? Of Y. So when it comes to the graphical display, if we want to determine the domain of a function, it will be the values of X for which you can see or where you can find the graph. Okay, let me put it that way. So the values of x over the graph, let me put it that way. So you have the graph spread over -4 to +2 here. So within this interval of x, you can locate our graph. That's what I'm saying. So within the interval -4 to 2, we can locate this graph. Outside -4, when you go here, you will not find a graph. The same way to when you go beyond +2, you will not locate this graph. So we say that the function exists over this given domain or this range of values -4 to 2. Okay. Let me touch on that. I think the marker was not clear. So what we are saying is, you see, the whole graph can be located from -4 to 2 over here. Okay, so this is the domain. The domain is the values on the on the horizontal axis. Okay, the horizontal axis. So the graph spans between -4 to +2. Okay, good. Now, another thing we have to take note of is, let me write it. So we are looking at the interval -4 to 2. When I bring comma, it means we are starting from -4 all the way to 2. Now, another thing we have to note is when the edge of the graph has been shaded. Please, those with your microphones off, mute it. So when the end of the graph has been shaded, it means that that particular value of x is included. Okay, so when it's shaded like this, we make use of the square brackets. It means it is closed or it is part of the domain. And then the same way, because the side 2 is also shaded, 2 is also part of the domain, so you close it with a square bracket. If it was open like that, if the edge was open, you open the brackets. If the edges were open round without being shaded, you have to just open it. It means that that particular point is not part of what? The domain, or it's not part of the interval we are considering. Good. Now that we have understood this one, we also need to write it in the set notation. I want to connect it to previous knowledge. Okay, so in the set notation, we would have written this information as what? X is such that x belongs to real numbers. Yeah, I think some hands are up. Jabril Mohammed. Mohammed, unmute yourself and ask your question.
Sir, please, I don't understand some concepts. The under vertical axis and the horizontal axis, the point was met at the vertical axis, which was the -4 and the +4, and the on the other side, the -4 and the +2. But when you see the domain and the domain at the top, the domain which was given for the -4 and the +2 wasn't like that. Sir, I don't understand. Please, can you explain it to me?
Okay, Jabril, your confusion is with what vertical is and what horizontal is. Okay, So when we say vertical, vertical is like that. Your building stands vertically, but horizontal is the floor. Okay. So when we say that the graph spans horizontally from -4 to 2, okay, just watch the values on the horizontal, that's on the floor. So let's say this is the floor, okay. So the graph starts from -4 here and then keeps moving until we get toward 2. So it's not about looking at the top and the down, it's just about looking on the floor, that's all. The domain is on the floor, not up and down. So horizontal, once again, is the floor, and then vertical is the way your building stands. Good. Let me take the next question. Albert, entry. Okay, if Albert is not muting himself, then let me take Eric.
Sir, please with a domain, assuming you have not been given a set notation,
Yeah,
and what you wrote down here with a range for, you've given a bracket saying means it's closed,
yeah,
and with a parenthesis down there means it's open, so
yeah,
it's not involved.
yeah.
Okay. So I was asking, assuming if you've not been given a set notation showing that it's less than or equal to -4, and you've been given the bracket, means it's closed or it's involved.
Well, you see, in the first place, you will have to develop the self-builder notation. So
Okay.
let me just go to this and explain again.
Okay.
So let's say we've been given a graph this way, starting from say -2, 3 here, and the graph looks something like that. Okay, and
Okay.
let's take another graph too, starting from maybe -4 to 6. This may look like so if we are to find the domain of the various functions, okay, in the first place,
Okay.
horizontal to horizontal will be from -2. In the first case, we have from -2 to 3 because it spans over -2 to 3. So our x starts from, okay, -2 and ends at 3. Okay, but because the edges are open, it means that we have an open space there. Okay, so they are not parts. -2 and 3 are not parts. So we use what? Open brackets. Then in the set builder notation form, we are going to write x, okay, so that x belongs to real numbers. Okay, starting from what? -2 is less than x, meaning x is not part of that. -2. -2 is not part of x, okay? And less than what? 3. Okay, good. Now let's come to second example. It spans from, so let me give that as an example, as an exercise. Anybody who's willing to attempt that should just raise the hand. So if you are willing to attempt that, raise your hand. Michael, do you want to attempt that? Or
Sir,
yes.
Mine was a question, but let me try
Okay,
to
then
answer
hold
this.
on, just hold on. Okay, Eric. So Eric,
So the answer is x is such that x is set real numbers of minus minus 4.
let's start with the interval notation first. So
Okay,
x
is such x is such that
x belongs to the interval
x belongs to with a close bracket
yes,
minus 4, 6.
minus 4,6.
6, yes.
Good. And let's write in the set builder notation.
Okay, x is such that
X is such that
x belongs to real numbers minus 4 less than or equal to
very good.
minus 6.
X
Less,
is less than or equal
less
to
than or equal to minus 6. Hey,
no,
6.
less than or equal to x.
6.
X less than or equal to
Less than or equal to
positive
6.
Good. So this is how we find the set builder notation. So when I give you, assuming I give you the set builder notation, then you should also be able to derive your domain for the graph. You understand? So sometimes I will give you the set builder notation and probably give you a function like this. F of x is equal to what? Is equal to 2x, okay, plus 2. So when I give you that, having the domain and the set build and the function just means you have to go back and reconstruct your table. Those who have your answer, wait a while. I need to explain this thing clearly before we proceed. So if I give you this, then all you need to do is you have your set of values of x in the domain here. And you also have your set of, you have your function value, okay? So x starts from -2, so you just have to list -2, -1, 0, 1, 2, 3. We are using the first case here, right? Good. Then you have to compute your f of x. You see, we say function is like a machine, okay? So just substitute your value of x into the function, put it in the machine, and then get the image. So if x is -2, then f at -2 will be equal to what? Will be 2 times -2, 2 times -2 plus 2. Okay, so that will be what? -4 plus 2, which will be -2. Then the next one, if x is -1, f at -1 will be what? 2 times -1, 2 times -1 plus 2, which will be -2 times 2, which will be 0. Okay, and then when x is 0, we'll have 2. When x is 1, we'll have 4. When x is 2, we'll have 6. When x is 3, we'll have 8. Okay, then after that, you just go ahead and plot your function. So you find a suitable scale, okay, and then plot. So we have -1 here, -2 here. You have 0, 0 in the center. We have 1, we have 2, we have 3. Then you choose suitable scale on the y. Let's say we are using for the lack of space, let me say 5, 10 here, okay, and then -5 here. So if I'm to plot this graph, it's just going to, it's a linear function. So this will be -2, -2, -2 for the first point here. -2 will be around this point somewhere. Okay, let me use a different color. So So negative, negative 2 will be around this point. Okay. Then the next value will be, let me do that first. Okay, so let's just use the star. Good. Then negative 1, 0. Negative 1, 0. X is negative 1, y is 0. Then 0, x is 0, y is 2. So x0, y2 will be here. Then x is 1, y is 4. So x1, 4 will be somewhere here. And then x is 2, y is 6. Please follow attentively. Follow attentively. Then 3 and 8 will be somewhere here. Okay. And then after that, this is the function. It's going to be a straight line. The function is going to be a straight line. Let me see. The function is going to be a straight line. Okay. From this point to this point. Good. Now, the point I'm making here with the closed borders and the open border. Okay. Let me touch on that again. Now, because the interval here, this is open, this is also open. So it means that x negative 2 and then x positive 3 are not part of the interval. Okay. So you have to draw an open space here and an open space here to indicate that they are not parts of the domain for the graph. Good. Now, having said this, let me take your questions. So I'll start with Albert entry. Albert entry.
Sir, please, good morning once again.
Good morning.
Okay, sir. I was following it, but quite unfortunate, I'm in a car, so my network went off. That's why I'm trying to call and ask a question whether any assignment has been given or anything has been given, but this one is not okay for me. So I can't
so,
read.
When it comes to issues of network, once again, I told you the video will be uploaded. Okay. So let's not draw the class back. We are working with time. Yeah, Jima, Bati. Yes. Oh, Jima, we didn't hear you. Yeah, continue.
Good morning, sir.
Yeah, good morning.
I think the guy has
Your network is not stable, but probably you may consider typing so that we address it for you. Timothy, I think Timothy Mensa.
Yes. Good morning, sir.
Yeah, good morning.
Sir, good morning.
Good morning.
Hello, sir.
Michael Ofosuhine.
Sir,
Yes.
I don't really get the brackets. The open and close. When is it open and when is it closed?
It is open when it's not shaded and it's closed when it's shaded.
Thank you.
You're welcome. So, Timothy, I'm coming back to you. Like I always advise, put off your videos because it also takes your bandwidth. So when your network is not stable, it's likely to be due to the video too. So Timothy, I'm back to you. Unmute yourself and ask your question.
Okay, sir. Good morning.
Yeah.
Please, I want to ask this simple question. Does the F bracket X on the table represent Y?
Yes, it does.
Okay. Okay. Thank you very much.
Welcome. Then have I left anybody out? I think Raymond Nati.
Okay. Yeah, I wanted to ask
Raymond, come again.
let's say the graph is hello.
Yes.
Yeah, I'm asking if how will I know if I'm supposed to plot it shaded or I'm supposed to plot it open? Well, when the rules are given or maybe the domains are given, will the brackets, when the bracket is there, I want to find out if there will be a bracket there or there will not be any brackets if the questions are given or something. So how I can plot it with shaded and without shading.
Raymond, that is just what I explained.
Okay.
So if it is given in the interval notation form and it is a curly bracket, you know it is open. If it is given the set builder notation and it is less than means that -2 less than x means that -2 is not part, x is bigger than -2. Okay, but if it is shaded, as in this case, you will see when we are writing it. Let me write that one. We wrote it earlier on. So if we were writing this one, because it starts from 4 to 6 and it's also shaded, it will be square brackets. Means that it is closed. Okay, so this bracket will tell you that you have to shade it. And in the set builder notation too, when you are writing it, it will be -4 is less than or equal to, means 4 is part, so you have to shade it, equal to x less than or equal to 6. Okay, then you put the set notation, the x belongs to real numbers. Okay, you to make it complete. So this is it. Either if it is given in the interval notation, you should be able to interpret it. If it's given in the set, you should be able to interpret it. And if it's given the graph too, you should be able to bring it to this point. Okay, so either way, you should be able to read and clearly understand to interpret. Okay, good. Yeah, let me see if I have final hand. I think I'll take Desmond. Desmond, yeah.
Good morning, sir.
Yeah, good morning, Desmond.
Please, there are two examples on your left side.
Yeah.
The first one, when you are listing the members, the one under, you didn't bring x is less than or equal to. So I was confused. But when the guy was answering the second one, he brought less than or equal to. So I wanted to know the difference for that one. Please, I'm done.
Yeah. Desmond, let's do a little exercise. If I say that
all right,
x is greater than -2, can you list the element of x for me? So list some values that are greater than -2.
Okay, I'll start from -3.
Greater than -2. Greater means
Greater.
you are yes. Values greater means you are going this way.
Okay, -1.
-1.
0.
0. Mhm.
1, 2, 3.
Good. So you see, -2 is not part, will not be part. -2 will not be part.
Yeah.
Now let's list x is greater than or equal to 4. List some elements which of x which are less than or equal to -4.
Okay, so -4.
-4.
-3.
-3.
-2, -1.
Good. So you see, in this case, -4 is part. And because it is part, we shade it.
Yes.
We shade it. But if it is not part,
Yeah.
like in the case of less than, you open it. Open means I am not part. That is what it means. Okay.
Okay.
That is what basically it
Okay.
means. Good. Yeah, I think we
All
are
right.
done at this session. Let's move on. Okay. Yeah, before, so this will be an assignment with relation to what we have just explained. So put it down, okay, and then solve it at your end for me. So put down this question and solve it at your end. I'm giving you some few minutes to do that. Then we can continue. Okay. So I want to believe you are far advanced with your solution by now. Let's just go to the whiteboard and solve it together. So the function there is f of x is f of x will be the function 2x squared minus 2 okay, and the given domain is -4. So I said if x is greater than -4, but less than what? Less than 2. Okay, good. So let's attempt to plot this graph. Okay, and like we said, once we've been given the domain, you just have to create a table and list the values of x and then find the corresponding images y. Okay, so this will give us so we have our x, we have our y. Okay, this time I'm not using f of x, I'm using y because they are the same. Okay, so we have our set of values of x to be 4, -3, -2. Then we have -1. We have 0. We have 1. We have 2. Okay. Then I'm going to take your answers for Patrick. Patrick, your hands is up. Patrick. Yes, Patrick.
Yes, we have a question. He said the only time we repeat the first number is when it's equal, less or equal to, or greater or equal to.
Okay, Patrick. I'll address that for you.
But here I can see -4. You've repeated the first repeat.
Patrick, that's enough. That's enough. I'll repeat it for you. Okay, so in the first place, I didn't say that the only time you're going to repeat that on the table. Okay, I didn't say that. I said in the graph. So take note of the difference. Now, I need your calculations for f of xy. Those of you who have computed that. So let me have upon Ima. Upon Emmanuel.
Okay, please. The answers. I want to give you the answers.
Yes, go ahead.
So the -4 is 29.
29.
-3 is 15.
15.
-2 is 5.
5.
-1 is 1.
1.
0 is -3.
-3.
1 is -1.
-1.
And 2 is 5.
2 is 5. Thank you. Thank you very much. So now that we have plotted the table, we can go ahead and I'm sure somebody might have an opposing view. Michael, let me just take you. Michael.
Sir.
Yes.
And the -1 is 0 for the y.
-1 is 0.
Yes. Yes.
Yes, that's going to be 0. That's true. So that will be -1 squared is 1 times 2 is 2 minus 2 is 0. Good. And 0 will also be -2. And then 1 is also going to be what? 0.
Yes.
1 will be 0. 4 times 2.
A more simple formula.
Please check your calculations again. You need to check them.
calculator no go fair. Me the buy you. So me buy me calculator and code. I'm out tuning now. You see, I don't call that.
Michael, your microphone is on. Okay. So this gives us -2, -2, and then this gives us 0. This gives us 6. I want to be sure the rest are correct. This is -4. So let's check it. 16 times 2. That will be 32. Oh, who's writing on the page? Yeah, let's try this one. Let's just do for the first one. Okay, so if x is -4, we have 2 into bracket -4 squared. Okay, minus 2. So that will be 2 times 16. It will be positive. Okay, minus 2. 2 times 16 is what? 32 minus 2. 32 minus 2 is what? 30. Okay, so that value 2 is wrong. Okay, so let's clean it. In fact, let's clean all the values and re-estimate. Okay, so this gives us 30. When x is -3, okay, we are going to get -3 squared is 9. 9 times 2 is 18. 18 minus 2 is 16. Then when x is -2, we'll have 4 times 2. This will be 2 times 4. So 4 times 2 is 8. 8 minus 2 will be 6. Okay. So these are the values we're supposed to get. Okay. Good. This is 2 here. Okay, so now let's go on to do the plot. I've seen a couple of hands up. Let me take Emmanuel Bedu. Emmanuel Bedu, do you have any issue? Emmanuel Techi Bedu, any issue? Emma, unmute yourself. Do you have any issue? Okay, your network is a bit poor. Let's take Mensa. Timothy. Timothy, do you have any issue?
Yes, please. Yeah, I want to confirm something. Please, I'm understanding something that negative number multiplied by a negative number should give you a positive number. Is it true? Because at first I was convinced it will give you a negative number.
No, at all. Okay. So having said that, let's go on to the graph. So let me have, where are we? Good. So let me graph, extend my graph a bit. Good. And I have from 30 to -2. So I'm going to have this here. Okay, and let's select our scale. We are moving on the horizontal axis. Horizontal means on the, let's put in the floor. From -4 to 2. So we can select point 1, -2, -3, -4. Okay. And then on this side, we have 1, +1, +2. This is X. This is Y. We are moving from -2 to 30. So let's take intervals of, let's say 5, if we don't mind. So that will be 5, 10, 15, 20, 25. Then we have 30. Okay, I think the last one. 30. Then on this side we have -5. Okay. Then what next? Let's plot our points. The first point will be -4. X is -4 and 30. Okay. So with eye judgment, we can say we have the point here. Then the next one is -3 and 16. So -3 and 16 is here. We have this point. Then -2 and 6. We'll have that point here. 10. So this will be 7, 7.5. So 6 will be a bit up. Let's plot it well. Okay. So let's say this is 6 up here. Okay, then -1 and 0. X is -1, Y is 0. Okay. Then we have 0 and -2. So -2 will be somewhere here. 0, -2. We have 1, 0. So X is 1, Y is 0. And finally, we have X is 2, Y is 6. So that should be somewhere here. Okay. And if we should connect this point, you're going to get, want to connect, sorry. Let's see if, okay. We want to, oh, my curve is not coming out nicely. Yes, that's much better. Yes, very good. So this is the point where you have to, okay, indicate whether the edges of the domain are parts of what? Of your plot, okay? So we said X is greater than -4. -4 is not part. So over here, -4, open the edge to let everybody know that -4, even though calculated, is not part of the domain and the range. Then at this point too, we are going to have 2 is also not part. So you need to open it. You open the, sorry. So we have to open that section because it's also not part, okay, of the interval. Good. Then having said this, so this is the graph. Okay, this is the graph. Now, Christian.
Sir,
Yes.
good morning.
Yeah, good morning.
Please, sometimes the graph, it will curve or it will be straight. It's not always that the graph will be straight.
Yes, Christian. So there are so many functions. From the beginning, I made you understand that we have several functions. We have polynomial, we have trigonometry, we have hyperbolic, we have algebraic functions. They all have the way they behave.
Yes, sir.
The plot that you are seeing there is the behavior of the function. And then I always say this, that you see current day robots, as we are seeing this thing here, okay, in a 2D surface, you see the ground itself is two-dimensional. You guys are building people, so let me just do this on a 2D scale. So on a 2D scale, this can be your y-axis and this is your x-axis. It still has 90 degrees. Okay, so it's the same thing here, just that this time I've tilted it so it's now the floor. Okay, so if I have a robot standing here and this robot is approaching, let's say, this box here, okay, but initially the robot has two functions programmed in the memory. The first function is y is equals to 2x plus 1. And then the second function is what we are working on here. Y is equals to 2x squared minus 2. Okay, these two functions have been programmed in the robot's mind. Okay, and the way it's been programmed is that when there is no impediment, when there is no objects, use this function. Okay, but when you meet an object, when there is an object on the floor, so and the floor is your x, so maybe we say when x is giving you an object, okay, and then when there is an object on the floor and when there is no object. So when there is no object, this is a straight line. You remember we've plotted it. It was straight. So if there's no object, then the robot will just move in a straight line. But when it gets close to the object and detects that there is an object, then it says that move in this curved path. So then the robot, when it gets close to the object, will move with this curve. Look at it. So it's going to move with this curve till it gets here. And when it gets here, because there is no object in front of it, it will move back to the straight line and continue with that function. You see, so in robotics and in so many fields of work, we have different functions which govern processes. So in the case of this robotic programming, okay, we can use different functions to govern the movement of the robot. And you need to understand the behavior of the function before you can even program the robot to do what it is doing. So in the designs of cranes for building, there are different automations. There are different programs that have been programmed on the control board for the crane. And they are all based on mathematical functions. So if you want the hand of the crane to move in a circular path, there is what you have to do. And if you want it to move in the linear path, there is also another function it has to be programmed to do. Good. So basically what we are doing here have very wide range of applications in real life. It's not just about plotting the graph, but when we plot the graph, it gives us an indication of the behavior of the process. So in real life, if we want anything to behave like the way we are seeing, then it means that we can just apply that function to such a process or such an object to behave like you are seeing in this function here. Okay, I've seen some few hands up. I'll take Michael. Yes, Michael.
Yes, sir. I raised my hands earlier,
Okay.
but I mean, the question was answered, so it's fine.
Okay, that's fine. Okay, so let's take Desmond. Desmond. Okay, Desmond's hand is down. Abdul Razak.
Sir,
Yeah.
please, for the calculation of the table, do you award marks for that?
Yes, I will.
Okay. Because
Raymond Nati.
Yes, I want to ask, will there be any circumstance where maybe, let's say, for example, -4 will be included and then -2 will not be included, or -4 will be not to be included in the graph? So you have to.
Raymond, I think we've gone through this already. And we did a demonstration with you. When the domain becomes less than or equal to, then it means that -4 is part. We've already looked at this. Okay. Then let me take one last question. Christian.
Sir, please. Sir.
Yes.
Please, you have already answered me.
Okay, that's fine. Then I think Ejekum.
Sir.
Yes.
And please, the 2 times 4.
Yes.
Is it 4 or because 2 times 4 is 8 and you wrote 18? So I just wanted to know if
you are not following. You are not following Ejekum. Shadrach. Shadrach.
Good morning, sir.
Yeah, good morning.
Please, I wanted to know with the calculation, is it going to work elsewhere and we fill in the boxes, the Y, or we are
You
going
show
to
working. Show working. So in exams, if I ask you to do it, you have to show working.
Okay, sir.
Good. Kojo Kakari.
Yeah. Okay, thank you, sir.
Kojo Karikari.
Yeah, sir, please. Sir, please. I understand everything, but you see where x is -4, y is 30. Due to the solution, it was 2 x bracket open. But say in the bracket, it was -4 squared. But the second solution of the answer, it was 2 times 4. That's straight 4. We don't know how the negative went.
Negative times negative is positive. So use that to cross-check your solutions. Zoom user. Zoom user, I've unmuted you. Zoom user, you raised your hand. I've unmuted you.
So they have already answered my question.
Okay, that's fine. Good. Now let's move on. We still have a lot to do and our time is almost used up. So let me clear this. So like I said, it's not just all about mathematics, like I'm telling you, okay? This mathematics is actually being used to govern processes in life. Okay, so take note of that. We don't just learn mathematics for grade sake. You learn to apply in scientific processes. Okay, good. So let's move from this board. Now, before we move away from this board, there is something we need to understand. In a two-dimensional motion, it's not all about the domain. We also need to understand, you see, the motion is where are we starting from? So if we are going to describe this person's motion, it has to be with the length and the breadth, you see, for the robot. You understand? So whilst we know that the length is the x, which is the domain, x is the domain, okay, we also need to understand the y values. What do they mean? The y values are the range. So the y values is also called the range, okay, in the mathematics sense. Good. Now, how do we obtain the range? When it comes to the range, you look at, how do we call it? The length on the vertical scale, okay, the length of the graph. So where does it start from? From bottom to top. Now, in this case, the highest value here is what? Is 30. My length doesn't look too good. Let me use a straight line from here. Good. So you see, we have 30 here. And then when it comes to the bottom side, we have -2. Where is this? We have -2 here. Okay. So in the same way, we can also write, please follow. Whilst explaining, that's not the time to be raising your hand. So we have the maximum value here is 30, and the minimum value is what? -2. So it means that y also starts from, when it comes to y belongs, the range also belongs to the interval -2 to 30. Okay, good. And if we are writing in set builder notation, then we'll say the range is such that y also belongs to real number values. Okay, and then y is greater than -2. Take note, -2 is not part, and less than 30. It's not part because we have an open space here, okay, and an open space here too. Okay, good. So whereas the domain is, the domain was x belonging to, okay, open brackets, -4 to +2. The range starts from what? -2, the bottom here, to what? The +30 over here. Okay, that gives us the range, okay, of the function. Okay, now let me see if I can take just one question. Abdul Razak. Abdul Razak, unmute yourself and speak.
Sir, please, you've answered my question.
Okay. Now, let me go on to we want to plot the same function we've just plotted, this time using a computer software, okay? And like we said, because these functions we are doing are applied to real life processes, if we can run a program on a computer and connect it to any machine, any device, any robot, the robot should also be able to listen to those instructions and function accordingly. And to, as a, let me say, as a first step to understand robotic programming, okay, we can also have the display of those functions on our computers. So we are going to use Scilab, okay, as a programming tool to, run or to study the behavior of this function and subsequently other functions which I'll ask you to observe or investigate on your own at home. Okay, good. So let me clear the screen. Having already seen this function, let's just go straight to Scilab and see the behavior of the function. Okay. Function. So you can just take note of it, 2x squared minus 2. And then the domain of x is in between negative. Okay, let's forward a bit. F of x, side. Now follow attentively with the Scilab. So on my screen, I have the Scilab 6.1.1 console, okay, which is very similar to MATLAB, very portable version, okay, and the language is C++. So if you have an idea of C++, that will even help. Now, like we said, our domain of the function x, okay, is equal to -4, okay, all the way to +2. So I have -4 is to +2. Please, can you see the console Scilab?
Yes, sir.
Good. So I've defined the range. Look at the interval of values it's giving me. -4, -3, -2, -1, 0, 1, 2. Okay, good. Now, my function is my y, sorry, f of x is defined as either f of x or y, because we know f of x is equals to y. Okay, so let's make it y is equal to, we were told 2x squared, so 2 times is multiplication is star, so 2 times x raised to the power 2 minus 2. Okay, that is the function we had. So once we type this and then enter, we have the values computed for us. Okay, so we want to plot our points and then see the graph of the function. You are going to use a plot command. So we plot x, y. If you are not asking a question, just mute your microphone for us. We do not want to hear. Okay. We have plot x and y. Once you press on enter, the command is initiated and the graph will show very soon. So that should give us it's taking a while, but it will come. Yeah, so this is the function of the point. You can see we have our point here. We have another point there. You have another point here. We have one point there. Yeah, so you will notice that it's the same graph we obtained, okay, by plotting manually. Let me do this. I want to display the manual and the computer display at the same time. So we have for, let me see if I can display the screen. Okay, it's unfortunate we can't bring both at the same time. But you see the graph we obtained. This is the graph we obtained. And then this is the computer display. Okay, so this is a computer display. You can see it's the same thing we had. We have a point here. Okay, and then the final points there. So these are the points we just plotted. -4 as against 30. Okay, that is it. -4 and 30. -3. So let me touch on this. I want to just insert something here to make it match. So this is a 1, 2. So when we draw, this is our axis. So these are axes. So you can see the point where we have -2 also below the graph. Okay. So in our case, we plotted at this is 0, 0. Okay, good. So this is 0, 0 here. Okay. Yeah, if you look at it carefully, so this is your 0 here. That's the 0 here, and that was exactly the point, the curve we obtained. Okay, good. Now let's continue with the computer display. And 16, -2 and 6, -1 and 0. Okay, so you select, let's say -1 and 0. You come and locate -1, then you gauge all the way to 0, which is on the y. Then you plot your point. Okay, the same with 0 and -2. Locate 0 on the x-axis. This is the x-axis. So you locate 0, this is 0. And then you are plotting 0 and -2. So this will be -2 here, -2. So you locate the point all the way, and then you go and plot that point. The same way, 1 and 0. So this is 1, this is 0. So you plot your 1 and 0 point here. Okay. And then finally we have 2 and what? So the last point is yeah, so our last point will be 2 and 6. Okay, so you locate that point 2 and then you plot it. Now this is how we can generate the plot of our function. Now by plotting this function, the most important thing I need you to understand is, you see, it tells us very much about this function. The first thing is, we know the domain of the function starts from where? -4 to 2. These are your x values, the domain. Okay, so this is the domain of the function. And then we also know the range of the function. The range starts from here all the way to the top over here. So this is our range of values. Then another thing we know is this curve seems to, you see, the curve is decreasing. You can see that the value of the function was decreasing whilst we were going until we get to a minimum point here. So there is a decreasing value of the function. The function was decreasing till we get to a certain point, then it begins to what? To increase. Okay, so here we are increasing. And such a point is first of all called a turning point. Turning point because it has changed, okay, the state of the graph. It's changed it from a decreasing state toward an increasing state. So it's a turning point. Okay, so we call it a turning point, usually represented as TP. But what type of turning point is this? Clearly, we can see that this point is down, down, down. So we call it a minimum turning point. So for a minimum turning point, the graph will always come in decreasing, but after that minimum turning point, it will start increasing. So every minimum turning point, while the graph is coming in, okay, or x increases, okay, when the graph comes in decreasing, it will end up what? Increasing after the minimum what? Turning point. So we call it a minimum turning point. Yeah, so this is quite interesting. We want to plot the same graph, okay, but this time around, or let's change it. The graph we've just plotted is a quadratic graph or a polynomial function, which is a function, say f of x, which is equal to 2x raised to the power what? 2 minus 2, given the domain. So this is quadratic, which is a polynomial function. Now let's take another polynomial function. Let's say f of x. We want to see the turning point properly and understand some other properties of what? Of graphs. So let's take f of x is, let's say, minus 3x raised to the power 4, okay, plus 2x cubed minus, let's say, x, okay, x plus 2, okay, good. So this is also a polynomial of degree 4. The degree is the highest power in the function, okay, so for x. So this is the degree. In this case, the degree is what? 4. The same way to this is the degree of the polynomial function. I'll show that to you. But since we are considering it, I'm just touching on that. So this is also the degree here. Here the degree is 2. That's the highest power in the equation. Okay. So I'm going to let's define the domain of x starting from, let's say, -3 to say 4, 4, and then that will be inclusive. So that will be our domain. So I'm going to graph it again. Let me clear portions of the Please mute your mics if you are not using them. Just mute it. Ernest, mute your mic if you are not using it.
Yes, sir.
Okay. So we'll define our x, which is our domain. Okay, starting from negative. Before we do this, I want you to know, instead of going like this, in the first case, the intervals were 1, 1, 1, 1. But if I want a very smooth graph, I can change the intervals and then rather make it 4. 4 is to half, meaning the interval should be smaller. Instead of using 1 as an interval, I'd rather use half. So 1 is to half is to 1. And I'm going to do same here. So this time I'm going to type x equals to minus 3 is to, I want an interval, a smaller interval. So half is to 4. Let's see the output generated. You can see it. So instead of moving from -3 to 2, -2, -1, 0, 1, 2, 3, 4, you see it's halved the interval for me. So from 3 to 2.5 to 2 to 1.5 to 1 to half to 0 to half, 1, 1.5, 2, 2.5, 3, 3.5, 4. Okay, so I've halved the interval. Now let me also type my function. So I have f of x, or let me say y, is what? -3 times what? X raised to the power what? 4 plus 2 times x raised to the power what? 3 minus what? X plus 2. Okay, good. So once I type it, it will give me the range of values of y. That is it. Yeah, I can see some hands up. Techno Spark.
Okay, sir.
Yeah.
I want to the choosing of the scale. Concerning the drawing of the graph. I'm not clear with that side.
You want to what?
Choosing of the scale for the graph. I want you to go to that side.
Okay, so for repetitions, you will see it once the link is posted. Zoom user. Zoom user. You don't have a name. Your name is Zoom user and your hand is up. Okay, let's continue. It's computed the values of y. Then I want to plot the function. So I'm going to use the same command. Let me clean this side. So let me use plot. So plot x, comma y. Okay, and then once we plot that, the graph will show. So this is the graph of the function. Okay, as we can see. Now I want to change. I want to see the behavior of the function properly. So I'll change the interval. Let's change the interval. We want to see it on a very larger interval. So let's say we are choosing an interval from -10 to +10. Okay, so let's change the interval. I'm going to change it from -10. Then this time I'll use 1/4. 1/4. That's 1/4 is to +10. Then I'm going to have the same function again. So y is this, and then I'm going to plot x and y. So let's see the display now. We have a smoother graph. Okay, it looks like a parabola, kind of getting constant along this line here. Okay, that is the kind of function we are having. It's still not very clear. We are supposed to have 3 turning points, but the graph is not really displaying it as we expect to see. Okay, but certainly that is the graph of, if we extend the interval, we want to see it clearly. Let's say if we pick from say -20 to +20, let's see what will happen. I want us to see the true picture of the curve. So let me use 30 this time. 30 is to 1/4. Okay, is to 30 mute the expression. Then I have plot xy. Okay. So certainly this is the nature of the graph. It's supposed to show the pattern somewhere here, the turning here, but we are really not seeing it. We are not seeing it. But that is the display of this particular graph. If we set the set of points, we are going to get the function as we see here. Now let's try another graph. Let's say this time we want to go. Let me go to my slide and see if we can get a very nice function. I want to plot. Let's get a polynomial function. Let's say, yeah. So we have a function like this one, x cubed. Let's have the function x cubed or x cubed minus 3x. So I want to use an interval, say this, and then plot the function x cubed. I want to plot the function x cubed, 3x cubed minus, let's say, we just saw 3x cubed minus 3x. Okay. So 3x cubed minus 3 times x. Okay. Cool. Then let's plot. Before you plot, you have to close the previous graph, else it will plot on the previous graph. So when we plot, yeah, beautiful. So we are seeing a very nice graph. Okay, it's giving us a different picture entirely. So here, this graph is very important for us. We are seeing that the graph we just looked at is x cubed minus what? 3x, okay, minus 3x, which is, that's the function. Oh, sorry, I think I mistakenly closed the player. Just give me. Precious, your hand is up. Cosec, the cos sign, we have log functions. They look like that. I'll go to the slides. We will look at it from the slides anyway. So log functions are of the form maybe 2 log of what? Log of x. These are logarithmic functions. So we can also have exponential functions. Exponential functions go this way. Okay, so we can have, say, a base raised to the power an x, okay, or more generally a certain base raised to the power what? X. A common example of an exponential function is e raised to the power x, which is the Euler's number. We'll look at that in the slide. So all of these are different functions. Then we also have what we call as the trig functions. The trig functions to come in their own forms. We have f of x, which is equals to cos of x. We have cos function. Okay, we can also have the sine function, sine x. Okay, we can have tan x. We can have cot x. Okay. Then we can have the hyperbolic functions to which are the cos x, the sin x. We have the sin x. We have the tan x. Okay, we'll be looking at their relationships. Okay, later in class. All of these functions are there. Then we have the cosec, the cosine. We have so many of them. Okay. So,
Okay.
what we want to do now is to just demonstrate how to plot them so that at home you can continue, okay, with the plots and examine how all these functions go. So let's try for the first one, which will be the logarithm function. So for the logarithm function, the domain should always be greater than what? 1, okay, or greater than or equal to 1. So we can choose x greater than or equal to 1 to the value, let's say x in between 20, okay, and then see how it will work. So let's plot that. We have x is 1 is to 20. So this time I'll half it. X is to 1 is to half is to 20. I want to suppress the data. Then the next one will be f, or y is 2 times what? Log what? Log of x. Okay, good. I'll suppress the output too, and then plot. We're going to plot x and what? And y. Okay. So clearly we are seeing the graph of this function here, which we just stated. That's the function. We just graph f of x is equal to that. So that gives us the nature of this graph here. Okay, good. Okay. Now, if we come to the exponential functions too, we can equally graph them just by raising the value of x to that power. Let me demonstrate one for the cos function. So for the cos function, let's demonstrate that. I want you to be able to plot all of these at home. So cos function, let's start from negative 360 to, let me use let's say half, or even 1 is okay. 360 to 360. I'll suppress the image. Then we want to y to be equal to, let's say, cos d of x. Okay, we keep the output. Then I want to plot x, y. Like I said, always make sure your previous graph is closed before you graph. So once we plot it, yeah, we are seeing what the graph of the function cos of x. Okay. Yeah, and then clearly we can see that given the domain, which is from negative, when you look at it, from negative what I stated, negative 300 to what positive 300 here, and then you realize that regardless of the value we give, y is always in between negative 1 and 1. So the range of the cos function or trig functions, the cos and sine functions, as we are seeing, is always in between what? Negative 1 is less than or equal to y is less than or equal to what? To 1, positive 1. So the function is always in between what? -1 and +1 for the range of values. Okay. Any questions on the plots we've done so far? Okay, so let me take some questions from the class before we wrap up for today. Yeah, so I have some hands up. Let me take Ofori Dennis Hansen. Ofori Dennis. Dennis Hansen, unmute yourself and go ahead with your submission. Okay, let me take Zoom user. Zoom user, unmute yourself. Oh, what's happening? TechnoSpark 4.
Okay, sir.
Yes.
Please, so choosing of the scale is my problem.
Choosing
I'm
of
not
scale.
that scale is my
Yes.
problem.
I think you have to go back to your Aquila, okay? Go back to Aquila. I think it should help you.
And the current process that you've gone through right now, like call, stash, and the rest.
Yeah,
I'm
when you go
appealing.
to Aquila, you find all those things. So go back to Aquila and revise. Okay. Yeah. Dream big. Your hand is up. Yeah, let me see you. Let me hear from you. Dream big. Let me hear from you. Your network is a bit poor. Your network is a bit poor. Maybe you can type Jefta. Let me hear from you. Okay. I think the lights are off in the to know the nature of the behavior, okay, of all of these various functions we talk about, the log functions, the polynomial functions, the exponential functions, the cost functions that we have plotted. I want you to practice them on your own and know the patterns of the graph. Now, before I even continue, if you were not in at the time we're taking the attendance, you want to send your name, okay, on the chat. Do that immediately before we wrap up the class. So if you've not done that earlier, send your name on the chat. Make sure your name is sent. That we are going to build up on the limits, because we'll be finding the limit. The limit deals with the behavior of the graph as we approach certain points. So you first need to understand how the graph behaves, okay, to continue from there. On that note, time is almost up, and I'm going to wrap up the class for today. See you all, God willing, next week. You have your pages, the links, and the materials uploaded by your course reps to your various pages. See you. Bye-bye.